Good morning, good afternoon, and good evening, everyone. Thank you very much for attending another one of our Wallaroo webinar sessions for October. We know that there's a lot of things competing for your time, and we do appreciate that you've chosen to spend it here with us today. We've got a great session coming up in the next hour where we will be building custom LLMs for production use in this topic. And we've got a great panel of AI expert leaders from across the industry. We have experts from Hitachi Vantara, from IBM, and also from our very own in-house Wallaroo VP of Product. And in this session, we'll discuss how to build, deploy, and also optimize your large language models for production environments. From the session, you'll also get information and best practices and learn about the strategies and the solutions for enabling your enterprise, and also if you're in the government space, to leverage LLMs at scale and drive that AI transformation for your real world scenarios, use cases, and other external customer or internal needs that you have. Now, just to outline the flow of the session, with each of our expert panel speakers, what we're going to do is they'll introduce themselves and we'll go through a short presentation so that they can teach their domain expertise and their business as it relates to building custom LLMs for production use. After each of the panelists have done, we'll then go into a panel discussion where we'll have some deep conversations on some of the best practices that you can then adopt and deploy from this session. Now, interjecting in between our speakers, we also have some poll questions as well, so that we can help get some information, and that will help us then nurture the conversations that we have. This is also an interactive session as well. Please feel free to use the Q&A, and we'll do our best to get to them during the session, if not at the very end. Thank you very much. And now to begin with, I'd like to introduce our first panelist, and I'll go through each one of them. Dr. P, if you'd like to come on camera, please, and give a quick introduction.
Hello, everyone. Thank you, Martin. Thank you, everyone, for being here. I'm Pragya Nayak, or as my colleagues call me, Dr. P. I function as Chief Data Scientist with Hitachi Vantara Federal, and I have over 20 plus years experience in the field of data science and in the federal sector.
Thank you, Dr. P, and thank you very much for joining us today. Looking forward to drawing some of that wealth of information from your brain so that we can all learn some of these best practices for custom LLMs. Our next speaker I'd like to introduce is Gina King, Director of Strategic Alliances and Software Partnerships at IBM. Hi, Gina.
Thank you, Martin. Hello, everyone. Very happy to be here today representing IBM. So as Martin said, I lead our strategic alliances with software partners, including Wallaroo for IBM Power. And for those of you, some of you may know what IBM Power is, you'll learn through this webinar and why it can make a difference for customers who are running large language models.
Excellent. Thank you very much, Gina. Really appreciate you having here on today's session. Our final, and by no means our last speaker and panelist and expert, is our very own Yunus Amar. Yunus, if you'd like to introduce yourself.
Hi, Martin. Thank you for having me. Hi, everyone. I'm Yunus Amar, VP of Product here at Wallaroo. I'm looking forward to sharing some of the best practices that we've learned throughout some experiences and engagements with our customers when it comes to deploying custom LLMs to production. Looking forward to this session.
Great. Thank you, Yunus, and we're looking forward to it as well. Now, before we get into each of the short panel presentation sessions, what we're going to do is have a quick poll question, as I mentioned, just so we can get a benchmark of where everybody is on the production AI spectrum. If you'd like to put up the poll question, please. And so what we're looking to answer here is to how soon do you expect your organization to adopt GenAI or LLMs? Could be within the next 6 months, the next 12 months, the next 2 to 3 years, or you might not have plans at all. So we're seeing some responses. through the next 6 to 12 months. Great to get these. And that is a great example of what we're seeing in the industry, where there is a lot of buzz and hype and excitement about LLMs. But it's also important for organizations to have a thought through this and think strategically of how do we take these and deploy these into production and make sure that they are optimizing our business and also impacting our business and our customers in the right way. Now, moving on to our first speaker, I would like to bring back Dr. P from Hitachi. And Dr. P, please, if you'd like to take us through your context for how you help organization build custom LLMs for production use. Over to you, Dr. P.
Thank you, Martin. So next slide, please. Yes. So as we saw from the survey response that people are in different stages of their large language model journey, and it is not surprising that some are, it seemed like an uniform distribution between folks at this helm of LLM, with they want to deploy something within 6 months, and some of them, and I'm sure it depends on the complexity of the application, why some of them want to play it safe and take 2 years. And how we play into that whole sector is that I work with Hitachi Vantara Federal, as I mentioned, as a chief data scientist, and we focus on the US federal government, the different agencies, primarily Department of Defense and the associated agencies. However, we do have a lot of work with the civilian sector as well. We are the foci mitigated arm of the Fortune 500 company Hitachi. By foci, we mean for and on control and influence mitigated, in order to be able to do work with the US federal government. We come with a rich history of having a number of implementations in the operational technology and the information technology space. So we're in that intersection of both those technologies and the analytics associated with it. And that makes us amenable uh, to the new phase of generative AI and large language models based applications in these various agencies and related sectors. Next slide, please. We are based out of Reston, Virginia. Just wanted to throw it out there. Uh, so when we are talking about building custom LLMs for production use, you do need good data to be able to work with it, and being able to have a tab on it, as well as the LLM deployment process. As Martin mentioned, being able to build, optimize, and deploy the developed large language models, and being able to keep tab on the drift associated with the both the data as well as the models and the process associated with large language models. So as part of my brief presentation, I'll be talking about strategies for overcoming challenges in scaling large language models for production use. The figure to your right on the slide, um, that may not be surprising. That's the typical mumbo jumbo, or the complex scenario that most of us have to deal with when we are working in a given organization's environment. Data is split across multiple domains. It's split by multiple different departments, but there's often a need where you want to work across data, not just across the different agencies and departments within the organization, but also across the different technology spectrum. That is the data on premise, or is it in one or more of the cloud providers? Do you have that kind of a hybrid setup? So trying to figure out what is the optimized way in which data can be accessed across these spectrum. In a convenient manner, without compromising security, without compromising the computing resources and the environment that you have going, you have as part of your organization. How do you do that in the most optimized manner? And then when we start talking about generative AI and large language models, it brings in additional challenges to that whole gamut of working with data. Next slide, please. So when working uh, un- with large language models or generative AI, you're working with data in the multimodal manner. And this data is often being collected, processed, and stored, but they're not being used today for any meaningful purpose. So large language models opened a way in which that data can be made useful, or it is relevant for you, and make that data accessible, and think of scenarios where they can be used. And I will be ending the talk with certain use cases in the public sector, which I think will translate into the other sectors. But this type of unstructured data is usually large in size, it's complex in nature. The traditional tools are not able to work with them in the most convenient manner. So you need additional, for example, metadata handling, so that you have a better control on that large volume, that large collection of these type of unstructured content, getting some structure into that unstructured data collection so that you're able to use it to its maximum advantage for these type of those seven use cases which are mentioned here. Today, these seven use cases are largely doable in the structured data or the semi-structured data space. But the moment unstructured data comes into the mix, there is a new challenge to it. The traditional tools are not well equipped to handle it. However, there are certain tools, including the tool I'll be talking about from Hitachi Vantara, which makes it amenable to work with this type of data. Next slide, please. And it's not just having access to the data and the unstructured data, but also the quality of the data is often the challenge. And that quality of the data is because of bias creep, which comes into the data due to various factors. Maybe when the data was collected, at that point, there was not a better understanding of certain components of the population. So, um, due to which there was no data collected for that particular part of the population. And over time, that understanding that the data is imbalanced and we need to fix that. How do you fix that as part of the analytics process, as well as the raw data which has been collected, that needs to take place. So intentionally, unintentionally, bias may creep in into the data which is being used for the large language models and overall general AI, generative AI, or traditional AI as well. And this is just hinting at the various different types of biases which can creep in terms of labels. There can be algorithmic bias where the nature of the data makes certain elements more conducive for the algorithm to consider those elements, but ignore the other elements of the data. And you are if you have that understanding of the algorithm, you will keep a tab on it. But if you don't, and um, you're going ahead with using an algorithm without understanding that intricacy, then that bias creeps into the process, and your eventual large language model or your AI model is biased in nature. So having a tab on these type of things um, is complex. And as I often say, that the devil is in the details of yes, we want to do an AI model, but being able to keep tab of so many different things in terms of complexity in the infrastructure, complexity in the type of data, and in the quality of the data is important when dealing with generating these models and actually deploying them and using them out in the field. Next slide, please. So in terms of the AI data and AI services, which will let you keep tab on those type of problems and get better at handling them, is to begin with your ETL pipelines, extract, transform, and load the data in the right way from the various data sources, various formats of data, finding related data, searching for data and within data. Both are two different aspects of doing your data integration, but being good in that via effective data integration and data management techniques is crucial. Along with, when you're dealing with unstructured data, metadata becomes even more important. Not saying that metadata is not important with structured data, but it is equally and more important when you're dealing with unstructured data, because that lets you get a better control on your unstructured content. And then as you're building your model, building your model, you're validating your model, and then using the model for inference. Finding the right data to use as part of that training and inference process is important, as well as keeping tab of the data and model drift analysis. And then once you have deployed the model, being continuously being able to do your data integration via whether it is databases, whether it is applications where you're using their APIs to do that integration. Are you using Python and R to do those Python and or Python or R services coding and applications to do that type of service deployment? That's important. And then being able to work in a real-time manner via your streaming data and your spatio-temporal analysis of the data. And over this entire process, having the right governance and compliance so that you have the data provenance and lineage, that is understanding where did the data originate and how has it been modified and used as part of the different processes in terms of model training evaluation, and keeping tab in all this, making sure that the security and access is not compromised while indulging in these type of applications and services. Next slide, please. And so even when we are looking at a simple large language model, the process is involved. It is not straightforward. Um, so I, if you're not already aware, I'm sure you'll get a new appreciation of all that goes on in the back end when you enter a query in one of your favorite large language models, be it ChatGPT, Gemini, or any of the other popular large language models out there. So on a very raw level, what happens is you take a document, be it PDF, Word, etc. You need to extract the raw text from it. What is the content of that document? Um, Extracting that can itself be a complicated process. But there are automated ways of doing that as well. Then from that raw text, depending on the size, you will want to chunk it out. And then from the chunks, you get the embeddings. And one of the simplest ways to think of embeddings is a vector representation of those text chunks, so that becomes and once you generate the vector, you want a vector database to be the place where you are storing that analysis which has happened between the data payload and the vector or the embeddings that you have formulated from it, and then using the vector database as your repository from where you are answering all the queries, etc. I know I'm simplifying. Even if this looks involved, this is also quite simplifying the large language model process. And the workflow that you're seeing below, that's from our application, where it shows how you can, Pinecone is one of the popular vector databases out there. You can create a free instance and you can do your experiments on it. So that's showing the work being done in the Pentaho application. Next slide, please. So I'm not going to spend too much time on this. We will go quickly through this, and I just wanted to show how the different components of the Pentaho Data Ops platform, which is a product that is offered by us from Hitachi Vantara, and Hitachi Vantara Federal takes care of the services and the understanding the federal requirements and mapping the product to those requirements. So it consists of a number of components. Pentaho data integration lets you work with a variety of data sources and enabling the data transformation. So for example, your database joins across different data that you're reading from the different platforms, be it via databases, APIs. Are you reading it from sensors or files? And then being able to also, if it is unstructured content, doing a metadata management, and then using an object storage platform such as our own Hitachi content platform, and then enabling the analytics in that process. And as part of your data integration, you can do your model training as well as your model inference. So that data being read, you're applying certain machine learning model. For example, object detection and identification, your computer vision models, that is something you can have as a part of the data integration process. So that, for example, as you're reading an image data, you're doing the object detection and identification. Okay, next slide, please. So this is some of the places where we are already present. It's Pentaho is an 18-year-old product. We are also deemed awardable in the DoD CDAO's Trade Wind Solution Marketplace. So definitely check us out there for the videos, etc., that we had created as part of that submission, and we are already present at a number of places. Next slide, please. So as I was showing in the architecture, this is a different view of the same, showing the Pentaho Plus data platform with the different components, and it should give you an even better idea as to where it will lie in the data manipulation process. And so Pentaho data integration, as you can see in the middle block, that is the one which can work with various data sources and doing your analytics process, your machine learning modeling, as well as the inference, and then passing it on to the data consumers. So this would be in the LLM context. This would be where you can invoke an LLM application via API calls and include your text analytics as part of your pipeline. For example, we have had use cases where we can use it to read content from the different documents and then pass that data payload, that text content, that raw text I was talking about, pass it on to an LLM model via API calls, and then get the required outcome from it. Um, is it your sentiment analysis? Is it looking at summarization of the content, etc.? And use Pentaho data integration for that process. The Pentaho data catalog is the data management. So it lets you do your data lineage, data provenance, as well as your automated in terms of the automation in terms of metadata generation from content. Next slide, please. So this I'll quickly skip over, but this should give you an idea as to how the data catalog looks. And you can see the metadata, the data quality metrics, as well as the data lineage in graphical form. And next slide, please. And this is looking at the low code, no code Pentaho data integration and analytics, how it can read data, and every step of the way as the data is being processed and manipulated and transformed, or the other terms you used is data fusion, data wrangling, your data engineering activities. Those are all enabled as part of the workflows that you're seeing here, including the data science activities as well, because you can apply your model tuning, model hyperparameter tuning, model training, validation, and inference as well as part of these type of workflows. Next slide, please. And this kind of shows you the end-to-end of the data engineering to the data analytics process, the end-to-end data pipeline orchestration that should make the whole building custom LLMs more convenient, automated, and orchestrated to perform. Next slide, please. So some of the use cases with LLMs in the public sector is in the space of semantic search, which is the most common, that you are using natural language processing to understand the context and understand the query and accordingly delivering the results. And that in turn enables the conversational chatbot so that users are not having to formulate the query in terms of keywords, but rather formulate sentences and getting the response back in sentences, as well as additional content which is multimodal in nature, returning you references, audio, video, and images as a response to the search being performed and or the conversation being held. Certain additional use cases are in terms of document understanding, all that large collection of documents which there was not a easy conducive convenient way to look at the content of that and understand. That has been enabled by large language models, so that automation makes the document understanding as well as the content summarization, exploring those large document repository, getting the keywords out of the content, getting a shorter summary of the content of that document, so you're able to better understand that data collection and which of those documents make sense for a particular use case that as a user you may have in mind. Next slide. And I just want to end off with talking about the benefits of the good data in AI and AI means large language models as well, since that's the focus of this discussion today. You're not just increasing the accuracy of your AI predictions and decisions, you're increasing the reliability. There is less bias. You have better control due to this automation and orchestration, better control on the data quality, and that in turn, you you have more efficiency in the process, you have fewer errors, and you're able to meet your regulatory compliance requirements while still taking advantage of the data and with reduced drift within your AI models. Uh, Next slide, please. And with this, I will hand it off to Martin and Gina, where she will be talking about some of the foundations that are very crucial for applications of this nature.
Thank you very much, Dr. P. That was excellent. I just before we move on, I just have a quick question. I loved the term bias creep that you brought up. It's the first time I heard of it. It's a great term because something like that can actually creep up on you, sneak up on a business if they're not implementing the best practices of monitoring and optimizing their models, and that output for the users. And along that vein, I just have a quick question. We hear a lot of talk about responsible AI and how how important is responsible AI in this LLM context when we do take into consideration things like bias, privacy, etc., and potentially harmful outcomes for the users.
Excellent question, Martin, and that's a good leeway into the concept and the field of responsible AI. With large language models and with AI today, literally we can think of it as um, you can do anything with these large collections of data, but does it make sense that you do if you're allowed to do it, you do it, but rather having certain guardrails so that things which are unethical in nature, which are going to compromise maybe privacy of the people privacy, the information privacy, as well as maybe as an organization, certain sensitive information, as a nation, certain sensitive information, all those needs to be kept under control and under the required protection are in places. So responsible AI provides that, as well as handling the misinformation and making the whole process more explainable and accountable towards accountable models with keeping security in mind. And one of the additional side effect of that is the environmental impact of all these models. We know how much energy goes into these different models. So having responsible AI as that overarching umbrella so that these type of factors are all accounted for and taken care of.
Excellent. Yeah, thank you very much again, Dr. P. And we'll see you in a few minutes on the panel discussion. At this point, I'd like to welcome in our second expert speaker, Gina King, Director of Strategic Alliances and Software Partnerships at IBM. Gina's going to go through how to scale LLMs for that high performance AI infrastructure. Hi, Gina. I'll hand it over to you. Take it away.
Thank you, Martin. Thank you. And again, very happy to be here on behalf of IBM. We're very excited about our partnership with Wallaroo. So I'm in my 21st year here at IBM. I started on the software side of our business. And for the past decade, or I guess I should say half of my career, have been on the hardware side of the business. So it's very interesting listening to Dr. P and talking about obviously data, right? Data is so important for AI insights, and also the large energy consumption that she mentioned around responsible AI. So what I'd like to do today is, for those of you who are not aware of, some of you I can guarantee have Power, which is one of our IBM hardware platforms, in your organizations today, whether you're using it in the cloud or on premises. But I want to give you an introduction to Power and also talk about some of the things that we're doing in the AI space. So Martin, if you can go to the next chart. For those of you who are not familiar with Power, it's an architecture, it's a process, and it's a processor rather, and it's a family of servers. So we've been around for over 3 decades. Our architecture and our processor have been around that long, and we have a lot of organizations, tens of thousands of organizations that rely on Power to run their businesses. So when you think about this, when you think about the architecture, you could think about other architectures that are out there. Just for comparison, x86, which is Intel and AMD, ARM, just as a couple of examples. So our architecture, our processor, the architecture of the processor defines how it functions and how the software interacts with it. That includes data. And there's a treasure trove of data in Power out there today. So we take those processors and we put them in our family of servers. And that family of servers include high-end, so where there are multiple upon multiple workloads running on those Power servers. We also offer mid-range and scale-out. And scale-out can be used for virtually any environment, including edge computing. As I mentioned, some clients, some of our customers will want to use Power in a public cloud, in a private cloud, a lot of them in hybrid environments. And so we make those options available for customers. And again, the entire family of servers is built with Power processors. Martin, if you can go to the next slide. We actually offer 3 different operating systems on Power. And what's unique about us is you can run each of these platforms on Power side by side. So I'll talk more about this in a moment, but what that does is it puts your AI in closer proximity to where the data lives. So our roots are really in AIX, which is a Unix-based operating system. We have a lot of organizations that run their databases on AIX today, as well as IBM I. So as I mentioned before, there's a treasure trove of data in those systems. And then, of course, we offer Linux. Everybody on this call, I'm sure, is familiar with Linux, and also containerized architecture like Kubernetes and OpenShift as well. So again, what's unique about us and what we can offer to our customers is you can run them all side by side in different partitions or virtual machines. You can do this on premise, you can do this in the cloud, and it definitely supports, having your AI and running large language models in proximity that's close to the data. Okay, Martin, if we can go to the next chart, please. So as I mentioned, we have a number of database technologies that run on our platform. And what we've been focused on for several years now is how we help our clients and more broadly the market in general with their digital transformation. Not only with hybrid cloud that I mentioned before, but also with AI. And we know everybody is talking about AI. Everybody's, as we learned from the poll earlier, looking at how they're going to use large language models within their organization, right, to help drive better business value at the end. So we strive with every generation of server that we release into the market on platform leadership. And I'll talk about this in a moment because for those of you who are not familiar with the platform, this is an area where we excel and we continue to improve with every generation. And it's also why so many customers around the world, so many organizations around the world run their mission critical workloads on Power. So in addition to that platform leadership, the other area that we're focused on, as I mentioned, is how we help drive digital transformation. Modernizing right within their organizations, whether it's with business applications, with DevOps, Also with generative AI, machine learning. So we'll talk a bit more about AI in a moment, and automation. So, and this is all offered to clients the way they want to consume it. So flexible consumption, meaning you use only what you pay for. I've also talked a lot about hybrid cloud infrastructure. So clients have the flexibility, and some clients, based on the industry that they're in, need to run their applications or continue to run their applications on premises. We know some are running in the cloud, and some want to have choice or flexibility to use both. And so that's what we offer with Power. Martin, if you can go to the next chart. This is where I'd like to spend most of my time, because this is what sets Power apart from other choices in the industry. Why we have so many clients that are running their mission critical workloads, continue to run mission critical workloads, and how we're continuing to build our client base after 3 decades of having the Power architecture in the market. So let me focus on the first one, because these are the reasons that our clients come to us, and why they rely on the platform. So one of them is around availability. We have greater than 8 nines of availability of downtime. That's annually is how we measure it, based on industry standards. And what that means is far, far less outage than what customers will see out there with other platforms. Clients can always basically be online 24/7. And this is so important for organizations. There are implications, right, when they go down, and enterprises want to make sure that they have uptime, that they have the uptime they need to support their organizations. The second area here is around total cost of ownership. And I think this, along with sustainability, is, so Dr. P, talked about energy consumption. The overall total cost of ownership for our customers who run on our hardware, again, whether in the cloud or on premises or in a hybrid environment, they're able, with our denser compute, they have higher server utilization than they will, particularly with our built-in accelerators. And I'll talk about our AI on-chip acceleration in a moment. But we're able to reduce the cost of a total cost of ownership for our customers, which ultimately hits the bottom line. We also work toward industry-leading scale and performance. So with every generation of server that we release into the market, our goal is to have 2 times better performance versus the other choices that are out there. And then kind of back to, related to TCO, but also this very much stands on its own, is sustainability, which has become increasingly important. Different industries, different geographies that we work in, and both from a standpoint of, reducing the amount of infrastructure that is needed, but also the overall energy consumption. And what we see there with each of our generations is anywhere between 40 to 80% better total cost of ownership as it relates to sustainability. And last but not least, when we introduced our latest generation of hardware, Power 10, we introduced on-chip AI acceleration. So we built the inferencing engine right onto the chip. And that's another area that we've seen, really impressive performance results. So as an example, you can inference a large language model in, less than a second. And we offer 42% more inferencing than the other choices that are out there. So very impressive results. And again, this is why, we have So many customers worldwide that rely on IBM Power as they're running both their kind of traditional applications and now as they're expanding into AI.
Gina, that's fantastic. We have a question from the audience, and it is, who let the dogs out? I'm sorry, that's not the question. The question is, this is great. It's great to see these benchmarks, and especially with the importance of latency and performance optimization, with custom models in production. And do you have any sort of key use cases that you can highlight that folks can then relate to, and they can say, I see this is how this benefits business?
That's a great question, Martin, and that's an excellent lead into the next chart. If you go there, for the sake of time, I won't highlight all of the use cases, but the use cases span across a number of different industries. I'll just highlight the one I think that is kind of my favorite, and it's a large retailer based in North America. They use a lot of AI models, more than 2.5 million to run their business. And the way that they're using AI on Power is twofold. One is to forecast demands, so they can actually forecast demands by customers for goods, right, that they provide. What that ultimately does is it saves them marketing costs. It allows them to tailor targeted customer segments where they have the highest potential for those goods. And then I think the other interesting aspect to what they're doing is how they plan stocking, how they plan to have inventory, so they can accurately plan which goods they order and which goods are in the store, so they don't run out and they don't end up with too much. So when they actually migrated from a high-speed GPU cluster to Power 10, and they ended up improving their turnaround time for training using AI models. How they measure performance is the models trained and applied over all of those goods. So they improved from 40 to 207 models per second. And that was related to their inference time for their long-term forecasts. And I think this is probably the most impressive thing is their speed. They had a speed improvement of just a little over 8.5 times. So that type of improvement have helped them strengthen trust and in their supply chain.
Excellent. Yeah, thanks very much, Gina. It's great to get that real world perspective for the folks on the session here. And just before we move on, just one last question. I started my career at IBM in Markham, Ontario. So great to connect and work back and develop the partnership that we are with Wallaroo. And through that, with IBM and companies like ourselves with doing this AI production, what are some of the key sort of technical advantages of partnering with organizations like ourselves on that Power 10 platform compared to some of the other available options?
Well, it's a great question, Martin. And I think, at the core of what we do across IBM and even more specifically in IBM Power, partnership is at the heart of that, right? So I think through our partnership, I would say there are two things, right? One, we help Wallaroo and your clients help improve, the performance, right? And I think Wallaroo plus Power that's an absolute hands down winning combination. We have not made this available publicly, so I would say to the audience, stay tuned here, but we have already seen some incredibly impressive performance results running Wallaroo on the platform. So that's one angle. The other angle here with regard to partnership is when we think about the different areas, kind of across our AI portfolio, whether it's workflows, we talked about infrastructure, the broader ecosystem, and AI solutions, the ability to, provide acceleration, how we build out the ecosystem. Wallaroo is a key part of that, and also very complementary to some of our existing portfolio, right? Like Watson X. So I would say, we bring a benefit very much to Wallaroo. And its clients. You also bring a big benefit to IBM and its clients.
Excellent. Yeah, we're really excited about this partnership. And thank you again, Gina. We'll look forward to having you back in a few minutes on the panel. Thank you again. Before we move on to our final expert, we have one last poll question, or actually a second poll question. So what's the biggest challenge? We've seen some great information so far. As before we go into more of the information on customizing LLMs, what's the biggest challenge when deploying LLMs in your organizations for folks that have taken that step? Are you looking at the scalability and that infrastructure cost? We talk about the cost of GPUs. Is it that model accuracy and reliability that we touched on with Dr. P and Bias Queep? Or all that real-time performance? Not all models are batch. You have real-time models as well, and they could be in remote locations, and so latency can be an issue. And also for your data science teams, the model monitoring and drift management that they need to take care of on a day-to-day basis so that the models are optimized. And so these are some of the questions that are very common. These are part of the best practices that organizations really should embrace. And so great to see that folks are looking at these things like latency and that real-time performance, so they can optimize that credibility and the accuracy for the folks that are using their LLMs. Thanks for your feedback. I'm going to move on to our final speaker, and I'd like to welcome Yunus Amar, a VP of Product at Wallaroo. And Yunus is going to talk through how we then optimize the deployment of custom LLMs for production at scale, and that is a critical component for any organization. Yunus, over to you.
Thank you, Martin. And next slide, please. So when we actually go and prospect our customers, or even collaborate with them on what it means to achieve effective LLMs in production, and most importantly, custom LLMs, as they basically move away from using the canned endpoints into something that is tuned to their own enterprise needs. The story remains the same compared to traditional ML. It's all about speed, quality, and quantity, which means I'm looking not in a particular order to realize value from my investment in LLMs, custom or otherwise, and how can I actually leverage the integrations in the ecosystem that I have built and put together to actually iterate quickly and make sure that I'm monitoring my LLMs effectively in production. And to that end, how can I actually do it tightly, proactively, without any disruption, without, again, exposure to bias or any performance issues? And as I build and measure and learn, how can I actually make that process repeatable and automated so that I build an industrial grade practice and operation to actually maximize the return out of my investment in LLMs, and of course the infrastructure that powers deploying these custom LLMs in production. So go to the next slide. The reality is, the theory is there, but when we look at the reality of what challenges we always run into, it's basically that time to value. Is it optimized? Not really. When you look at the complexity and the amount of engineering that is required to actually build and scale, especially custom LLMs in production, that's one of the challenges, in addition to, of course, the infrastructure that goes along with that, as well as the amount of control that is required or sometimes is necessary to make sure that you're maximizing performance out of that infrastructure. And then finally, how can you actually proactively account for bias? We keep talking about bias, responsible AI. It's truly one of the challenges here that basically prevent enterprises from launching LLMs effectively and reliably in production. So when we come in, next slide, please. As a product and as a team, what do we focus on today? We focus on, when it comes to custom LLMs, on deploying efficiently, making sure that we meet you where you are as a customer with our product, with our expertise, and get you up and running quickly with a framework that allows you to proactively monitor and iterate on your models, as well as the optimization of LLM performance in production, maximizing the utilization of the infrastructure that you have available. Think power, think GPUs, think x86, whatever is available. How can you actually maximize the utilization of that infrastructure without necessarily biasing towards a single one of them, to get the optimal performance when it comes to inference out of your LLMs. Next slide, please. So diving into each one of those components, when it comes to deployments, and especially with custom LLMs, one of the things that one of the practices and solutions that we have seen repeat itself is this idea of retrieval augmented generation, which is one of the most optimal and popular techniques out there to actually limit bias and hallucination, using this idea of vector index database and deploying LLMs that are actually working within a specific context, so they don't necessarily deviate from the realm of answers that they can provide. So Wallaroo, from a platform perspective, enables a framework, a customization framework that allows these RAG pipelines to be deployed as a single inference pipeline using Wallaroo, with a tight integration with the end application, where that will be powered by the LLM, as well as the underlying vector database in the customer's ecosystem, to actually make sure it's drawing from the relevant data, while also building automation to continue to enrich these vector databases with appropriate context, using things like embedding models. Some of them are known as those BGE models that you see today within Hugging Face and other similar models. Next slide. And of course, when we talk about LLM monitoring, we cannot basically talk about it without mentioning the Wallaroo's proprietary LLM listeners, which today enable effective monitoring from the perspective that if you are launching an LLM, you can be looking for specific metrics around harmful language or toxicity, or things that ensure that you're not out of compliance in terms of the quality of the answers that you're generating from a healthiness standpoint. But also, when we talk about custom LLM listeners, we enable the same facility where an enterprise customer can actually tune our LLM listeners for a specific context. One of the recent implementations that we have done in this framework is the ability to actually score customer intent once they interact with an LLM, with a chatbot, to see if that's a qualified customer for our enterprise customers, or if that's something that needs to be pushed down the queue and prioritize only the qualified customers for the next follow-up. So in terms of the solution itself, how it works today, it's basically a set of automated LLM listeners that are fully orchestrated within the Wallaroo platform, with alerts and metrics that score on the fly that interaction, which enables the AI operators, or basically the users of Wallaroo, to ensure that these LLMs are driving effective value for these deployments in production. And then next slide, please. Last but not least, when we talk about performance, especially with custom LLMs, as you start basically leveraging those, the first thing that will come up is how can I actually maximize the performance of the infrastructure that I have available? As I mentioned, whether it's GPUs or IBM Power servers or x86, there are techniques that need to be considered to actually maximize throughput, minimize latency on the target hardware. And the techniques that we have implemented today to actually ensure that there's a good trade-off between cost and performance are for frameworks that are available for custom LLMs, mainly Llama CPP, to actually drive maximum performance on CPU, as well as VLLM to drive maximum throughput primarily on GPU, as well as auto-scaling techniques to make sure that you're utilizing the infrastructure effectively, minimizing cost, as well as one of the famous techniques that we are actually launching in the next couple of days around dynamic batching, especially for concurrent requests, where you're actually holding the request to ensure that you're utilizing whatever infrastructure you have available efficiently without basically creating unnecessary queues and reducing the performance of the LLM-enabled application. So with that, if you don't mind going to the next slide, Martin. We have a set of resources that will be available shortly to actually come to us and ask any questions that you may have on LLMs and how you can deploy them in production with Wallaroo.
Thanks, Eunice. I appreciate that. Throughout today's session, and throughout what you've just went through, we hear folks talk about out in in forums and whatnot. We talk about optimal model performance in production. What does that really mean for an enterprise, and how can they best achieve that or
It's
drive
really,
towards
yeah, thank you. Sorry to interrupt.
that?
It's really twofold. There is the performance on available infrastructure, meaning inference response time. That is super important, especially for launching real-time applications. Chatbots are certainly one of them, even for batch applications in terms of the throughput that you can get through your available infrastructure. That is one of the considerations. That's where the techniques that I just mentioned in my previous slide around dynamic batching, as well as leveraging scaling, are certainly helpful. And those are one of the techniques that our customers report today, and we're helping them actually leverage within Wallaroo to accelerate their LLM deployments. Then there is the other performance management aspect, which is around, I call it drift and anomaly prevention. Which is, if you detect it and don't do anything about it, that's a moot point. You actually want to make sure that you have a proactive framework that detects things around bias or even drift or any issues with your LLM, so you can effectively address them and handle them in the platform before it's too late and before there are issues that may cause some damages that will be hard to recover from.
Excellent. Thanks, Eunice. I would like to invite our panelists, Dr. P and Gina, if you'd like to come on screen. And so we'll go through some a quick discussion, as I mentioned at the beginning. And if the audience has any questions, please feel free to jump in. And what I'd like to ask the panel is, not all models are created equally. You have different sizes of models, needs, etc. And if each of you can give me, one or two sort of key strategies or best practices to help optimize the performance of these custom models when you're deploying them into production. Too, as the audience poll suggested, their concerns are around, latency, resource usage and scalability, and for both real-time and batch scenarios.
Yeah, I can go first, actually, since I was still talking. I think the main consideration here is really the size of the problem and the size of the data that you're working with. Small problem, small data does not require a Llama 7DB model. We've seen that time and again, where there's hype around what it does, and then you go and see it in the field, and you're basically bringing a cannon to kill a fly, which is highly unnecessary. So in my opinion, before diving any deeper than that, it's really starting with the problem, understanding the size of it, quantifying it, qualifying also the magnitude of what you're looking to solve to be able to actually come up with the appropriate solution. Starting with the solution, in my opinion, never yields effective results. But yeah, Dr. P, what do you think?
Absolutely, plus one to that. And the other term that we often hear is the small language model. So for every so define your problem. What are you trying to address, and make it context sensitive. Reduce the scope of the problem, because small language models will also mean that you're working with lesser resources, computational storage, all that involved is much lesser. It's much more specific to the problem or the domain that you are operating in. Not everything requires a large language model. So being able to work in that space. Gina, what would be your thoughts on that?
I agree. I would just add one thing, which is run them on an infrastructure that can deliver the kind of performance you want.
Excellent. Okay, great responses. And one other question that we have is, we've all seen stories, unfortunately, as data's, and businesses evolve, we've seen these stories of, toxicity, hallucinations, and that erodes the customer trust and credibility, and in some cases can also lead to unfortunate lawsuits, as we've seen in some cases as well. And how can organizations bring about the practices easily and quickly, without overhead, to maintain these models in production, to make sure that we don't get bias creep, that we get solid, credible outputs for the customers?
I can take the first stab at this. I would say you need the required automation and orchestration so that you're keeping a tab on the data quality as well as the drift in the data and the models, which is something which I really appreciate in your Wallaroo.AI infrastructure and the process involved. So something having those type of automations ke- makes it a lot more convenient. Um, Gina, would you like to add something?
So I'll put my broader IBM hat on at the moment, and this is probably the number one concern, right? Governance of AI amongst CXOs, right? As they know they need to deploy AI, but there are some concerns associated with it. I would encourage our audience to look at IBM Watson Governance. So it can be used not just with IBM products, but other products within the industry. And so I think it would most definitely address some of those concerns, Martin.
Excellent. Eunice, would you like to add something?
Absolutely. There's one thing that I wanted to add here, which what I've noticed in the market is with the emergence of LLMs, there's one practice in particular that feels or felt underappreciated for a little bit until the lawsuits started to creep up, which is data science. I think when it comes to these LLMs being in production, there needs to be some effective monitoring, and there's science that goes into monitoring to actually understand what is relevant, how bias is defined for that context, for that data, to be able to monitor it effectively. That's really what data science is all about. And that's honestly what was at the genesis of our LLM listeners, which is bringing back data science practices into LLMs and basically showing that without those skills, you will not be able to build that tight feedback loop between the LLM in production and the data behind it, or the value it creates at the end of the day. So yeah, I will definitely index on data science practices here.
Excellent. Thanks very much. One last question. I think we're a little bit over, but I think this is a great question to have. Given the topic today of building custom LLMs, for production, uh, what are the key factors then that businesses should consider when they do decide to build custom LLMs, versus taking pre-trained or other models, given some of the hype and maybe there's a panic element there. How do they thoughtfully go about customizing their models?
Yeah, I think I can take a first stab here. Uh, there are a couple of considerations. The first one is really security and the where you want the LLMs to run. I think a lot of custom LLMs come in as a result of wanting to run in a secure environment where data is not necessarily accessible, and there are higher compliance um, uh, constraints around it. And the other one is really performance and control over the infrastructure that you would like to utilize to run those LLMs, which you don't necessarily get with things like LLM as a service. So those two, in my opinion, are some of the constraints and considerations that would be looked at for custom LLMs.
Absolutely, and what Eunice just mentioned. I'll just add that it also depends on the availability of resources in terms of your data scientists and data engineers. So you're keeping a tab on your data quality and your data engineering so that appropriate data is available for doing those training processes. And one analogy I often use is looking at uh, are you competent enough to, when you're preparing dinners, do you go for the TV dinners which are out there pre-packaged with standard taste, or you have the necessary cooking skills to prepare something on your own from scratch with the right ingredients attuned to your taste? So accordingly, pick and choose, and go on that journey and come up with the right solution in the right time and timeline it.
Yeah, I think
Excellent.
that's a great analogy, Dr. P. And I would say, Martin, this is why I think creating custom LLMs or leveraging LLMs that exist in the market, or exist already that clients can use. This just accentuates, I think, why our partnership with Wallaroo is so important.
Excellent. Thank you very much, Dr. P. Thank you very much, Gina. Do appreciate you, and also Eunice as well. A great in-depth content from all of you on the subject of building custom LLMs for production. And if you want your technical teams, your data science teams, MLEs, to understand more on this topic, we have an upcoming live stream event on the Microsoft Reactor on October the 31st. You can register here. We'll also be posting on our LinkedIn feed as well. So thank you very much, and look forward to seeing some of your folks there. If we go to the final slide here, we also have some great content and further information on custom LLMs, as well as other solutions and use cases and industries on our website. And as I mentioned, we have a regular posting of useful and very highly relevant information on LinkedIn, as well as on what used to be known as Twitter. And finally, just one last thing is to thank everyone here. I know, as I mentioned at the beginning, it takes, you're very busy. It takes a lot of time out your day to attend this session. We do appreciate that you chose to spend it with us today, and we hope it was valuable for you. And we look forward to seeing you on future webinars as well. Thank you and good day. Bye-bye.